Good morning students, welcome to the class. In today's class we are going to discuss few more concepts and the formulas related to the Incentre. Okay, and in previous video we just discussed that what is Incentre, how can we find out the Incentre of the triangle, and we just discussed the two basic formulas for the length calculation of the Inradius of the triangle. Okay, now we are going to move forward, and in this video we will discuss few more formulas for the length calculation of the Inradius, and along with that we are going to discuss few more things. Okay, in previous video we just discussed if length of all three sides of the triangle is provided, that how can we calculate Inradius. The formula was r equal to del upon s. The del is representing the area of the triangle and s is representing to the semi perimeter of the triangle. Okay, and another formula was that 1 upon r equal to 1 upon h1 plus 1 upon h2 plus 1 upon h3, and this formula is to be applied when all three altitudes, the length of all three altitudes of the triangle is provided in the question. Okay, now we are going to move forward. Now we will discuss the formula of Inradius when there is a right angle triangle. Okay, suppose the length of all three sides of the right angle triangle is provided in the question, and the examiner is going to ask you that calculate the length of Inradius. In that case this formula can be applied. Okay, so suppose there is a triangle and name of the triangle is ABC. Okay, and this is the triangle ABC. Okay, and I'm saying that angle B equal to 90 degree. This is angle B and this angle is 90 degree. Understand that? Now tell me, this angle is 90 degree and this is the largest angle, and you very well know that the side opposite to 90 degree will be known as the hypotenuse. So this is the hypotenuse and this will be the perpendicular and this will be the base of the triangle. Okay, suppose the length of all these three sides is provided in the question, and you just have to calculate the length of Inradius. In that case this formula can be helpful for you to calculate the length of the Inradius. So Inradius will be equal to perpendicular plus base minus hypotenuse divided by 2. This is the basic formula, and you know, if you want the proof that how this formula is derivated, I can tell you the proof also. So now we are going to discuss the proof of this formula. Okay, so proof is that, you know, basically we discussed that r will be equal to del upon s, and del is representing to the area of the triangle and s is the semi perimeter. What is the semi perimeter? Semi perimeter means sum of all three sides of the triangle is known as the semi perimeter. Understand that? So this is the basic formula for the length calculation of the Inradius. Now tell me, what is the formula of area of right angle triangle? You can say area of right angle triangle will be equal to 1 by 2 p into b, and s will be equal to p plus b plus h upon 2. So I am replacing these things over here, and I am writing area will be equal to 1 by 2 p into b, and s is equal to 1 by 2 within bracket p plus b plus h. Okay, and 1 by 2 cancelled. Okay, now we just have to replace perpendicular multiply base so that we can get this particular formula p plus b minus h by 2. Okay, can you tell me, you have studied about a plus b whole square, okay, in algebra, and you very well know that a plus b whole square will be equal to a square plus b square plus 2ab. So I'm saying that p plus b, I'm saying that p plus b whole square will be equal to p square plus b square plus 2pb. Okay, p square plus b square plus 2pb. Now I can say that you very well know, because of the Pythagoras theorem, h square will be equal to p square plus b square. You very well know this. Okay, so I can replace p square plus b square with h square. So I can say that p plus b whole square will be equal to h square plus 2pb. Is that clear? Now we can say that p plus b whole square minus h square, 2 is multiplying here, so it is going to divide in left hand side. It will be equal to p into b. Okay, now I'm going to replace perpendicular into base with this particular derivation over here. So I can say that r will be equal to, as we know that r equal to p into b upon p plus b plus h. Now we can say that r will be equal to p plus b whole square minus h square upon 2 within bracket p plus b plus h. Okay, I just replace perpendicular into base with this particular derivation. Okay, now you have studied about the formula a square minus b square in your previous classes, and you know very well that a square minus b square is equal to a plus b multiply a minus b. So what can we do over here? We can say this is a square and this is b square. I'm going to apply the identity, algebraic identity. A square minus b square is equal to a plus b into a minus b. So I can say that it would be equal to p plus b plus h, and within bracket p plus b minus h, okay, upon 2 p plus b plus h. Getting me? Now p plus b plus h cancelled. Now what you get? It is p plus b minus h upon 2. So this is the process of the derivation of this particular formula for the length calculation of Inradius in a right angle triangle. Okay, so you can apply this formula directly. For the purpose of solving the questions, you just have to remember this particular formula. Not the proof is essential for the examination, but I'm telling the proof because it is just going to strengthen your mental ability. Okay, it is just going to strengthen your mental ability, way of thinking in the question. Whenever you are going to face a new kind of question, these kind of things are going to help you in your examination, especially when you are going to fight for CDS examination. You know, when you are going to see some kind of questions related to the CDS previous year examinations, okay, you will see that if you know the concept from the basic, okay, and you are diving very deep, okay, then you can easily crack the paper, and you can simply simplify all the questions of the mathematics. But you should know all kind of knowledge from basic to advanced level. Okay, so now I'm gonna to move to the next question, and we will discuss the next question over here. Okay, and question says that there is a right angle triangle. Okay, there is a right angle triangle, and in right angle triangle ABC, in triangle ABC, angle B equal to 90 degree, angle B equal to 90 degree, and it is said that length of sides of triangle is, length of sides of triangle is 7 centimeter, 24 centimeter and 25 centimeter. 7 centimeter, 24 centimeter and 25 centimeter. Okay, we have to find in radius of the triangle. We have to find in radius of triangle. Okay, we have to find in radius of triangle. Now you very well know that this is a right angle triangle because it is already mentioned in the question that angle B is equal to 90 degree, and length of all three sides is provided over here in the question. Okay, and you very well know that 25 is the largest side, so it is gonna to work as the hypotenuse of the triangle. Okay, and the examiner is just asking to calculate the length of the Inradius over here. So what we are gonna to do over here, we are just simply gonna to apply the formula of the length calculation of the Inradius. So you very well know that Inradius R will be equal to P plus B minus H upon 2, and we are going to place the values over here. You very well know that perpendicular will be equal to 7, base is 24, and hypotenuse is equal to 25 minus 25 upon 2. So 7 plus 24, 31 minus 25, it's 6 upon 2. So Inradius will be 3 centimeter. So I think you would have better understood this formula. Okay, and you have know the conditions when this formula is helpful to apply in the questions. Okay, this is only for right angle triangle. Okay, now we are going to discuss one more formula, and that formula will only be applicable on equilateral triangle. Okay, firstly we are going to discuss that what is an equilateral triangle. You already know that equilateral triangle is a triangle in which each side is equal. Okay, that is equilateral triangle, and each angle is gonna to be 60 degree. That is equilateral triangle. Okay, so now we are gonna to discuss the formula of the length calculation for equilateral triangle. Okay, we will discuss the formula for calculation the length of Inradius for equilateral triangle. Suppose this is an equilateral triangle. Okay, This is an equilateral triangle. If this is an equilateral triangle, then each side will be equal, and let's assume length of each side is a centimeter and each angle is 60 degree. Now firstly I'm writing the formula, then I'm gonna to tell you the derivation of this particular formula. Okay, so when examiner is asking you to calculate the length of Inradius, okay, so length of Inradius will be a upon 2 root 3 for the equilateral triangle. You have to keep this formula directly in your mind just to simplify the questions. Okay, but I'm going to tell you the proof of the derivation of this formula. Okay, so proof says that in previous session we have discussed that, okay, in previous sessions we have discussed that r will be equal to del upon s. Small r will be equal to del upon s, and this is the equilateral triangle. You already know that del will be equal to root 3 by 4 into a square, and s is sum of all three sides by 2, so this is 3a by 2, this is 3a by 2. If we are going to simplify this, root 3 by 4 a square into 2 upon 3a, okay, a will be cancelled with a square, root 3, and this 3 can be written as root 3 multiply root 3. Okay, I'm writing like this, root 3 multiply root 3, root 3 cancelled. Okay, 2 is cancelled by 2, a square will be cancelled by a. Okay, so a will left over here. Okay, so a upon 2 root 3. So this is a very basic process just to understand the derivation of this particular formula. Okay, so you have to apply this formula for equilateral. The previous one will be applicable only for right angle triangle, and in previous video, in last session, okay, we discussed two basic formulas for the length calculation of Inradius, and those formulas were applicable for all kind of triangles. Okay, now I'm gonna to give you a question for the better understanding, and the question says that suppose there is an equilateral triangle. Okay, there is an equilateral triangle. In equilateral triangle PQR, in equilateral triangle PQR, length of each side is 18 centimeter. Length of each side is 18 centimeter. Then find in radius of the triangle. So we are gonna to simplify this. Find in radius of the triangle. So if this is equilateral triangle and I'm drawing the triangle over here, and name of the triangle is ABC. Okay, suppose, okay, and each side is given 18, and we have to calculate in radius. So we know the formula of in radius, r equal to a upon 2 root 3. We don't need to draw the diagram, actually I just drawed it. Okay, a is 18 and upon 2 root 3. 2 will be cancelled by 18 9 times, 9 by root 3, and just applying rationalization we will get 3 root 3. So this is in radius of the equilateral triangle if each side is 18 centimeter. Okay, so these things are very simple. You just have to keep the formula in your mind. After that you are gonna to simplify the questions. Okay, now one more concept I'm gonna to tell you about the in radius, or you may say it belongs to Incentre. Okay, in many questions it will be asked to you. Suppose we have discussed that what is the Incentre. We have discussed that. Okay, Incentre is the intersection point of all angle bisectors. Okay, so it means each of the interior angle bisector is going to pass through the Incentre. Okay, so suppose this is triangle ABC, this is triangle ABC, and I'm saying this is Incentre, this is angle bisector AD. Okay, this is angle bisector, it means both part of angle A will be equal. Suppose this is theta, this will be theta. And now tell me, if AD is angle bisector, AD is angle bisector, okay, AD is angle bisector over here, then this AD will be passing through Incentre I. So this is Incentre I. Okay, this is Incentre I. So in many questions you will be asked to calculate AI ratio ID. Okay, AI ratio ID means the examiner is just going to ask you that tell us that in which ratio Incentre is going to divide the angle bisector. Okay, so always remember AI ratio ID will be equal to, okay, AI ratio ID will be equal to, and for the calculation of these ratios the examiner is going to provide you length of all three sides. So suppose length of this side is C, length of this side is A, and length of this side is B. Okay, so length of all three sides of the triangle is provided over here. Okay, and we have to calculate AI ratio ID. Okay, so what can we do? Suppose the angle bisector is dropped right from vertex A and meeting on side BC. So AI means the distance from Incentre to the vertex will be defined by the sum of other two sides. Okay, by the sum of other two sides. Which other two sides? So you have to skip the side on which the angle bisector is meeting. So you have to take the sum of other two sides. Okay, so AI will be equal to B plus C. Understand? Now we have to calculate ratio of ID. ID will be in ratio of the side on which angle bisector is intersecting or meeting. So angle bisector AD is meeting on side BC, so ID will be A. Understand that? And it is happening because of the ratio we have discussed in angle bisector theorem. Okay, what was the angle bisector theorem? We discussed in angle bisector theorem that angle bisector is interior angle bisector is going to divide opposite side in those ratios in which other two sides are. Okay, so here the ratio of other two sides is B ratio C. So this A unit will be divided in ratio of B ratio C. B ratio C. It was kind of concept over there. Understand that? So because of this ratio, AI ratio ID will be in this same ratio. Getting me? Okay. So now I can say, you can say that I'm just connecting B with I. Now you can see the triangle ABD. You can see the triangle ABD. I'm going to calculate length of BD. You know, here the ratios are B ratio C. I'm talking about the proof. Here the ratios are B ratio C. So suppose I'm saying that Ram and Shyam, there are two friends. They have some amount in 3 ratio 2 and total rupees are 80. Total rupees are 80. So what would you do? Total 5 unit equal to 80. So in the same way, I'm gonna to say you that B ratio C, total ratio is B plus C, will be equal to A unit. Will be equal to A unit. So if I'm gonna to calculate BD, so firstly I will calculate 1 unit. So 1 unit ratio will be equal to 1 upon B plus C. If I want to calculate length of BD, that is represented by ratio B. So B will be equal to AB upon B plus C. Now in triangle ABD, I'm just gonna to apply angle bisector theorem. You already know that ABD is a triangle and BI is angle bisector. So AI ratio ID will be equal to AB upon BD. AB upon BD. Okay, AB upon BD. Okay, I made a little bit mistake. The mistake is that the ratio will not be here B ratio C. The ratios will be C ratio B. Ratios will be C ratio B. Okay, I just wrote it in reverse order. Okay, and here the value will be C. Okay, this was a little bit mistake. Now AB is C unit. I am placing that, and BD is AC upon B plus C. AC upon B plus C. So you can see that C will be cancelled. Sorry, C, not C. A will be cancelled. Yeah, exactly. C will be cancelled. What the hell is happening? C will be cancelled and it is going upward. So B plus C upon A. So this was the proof. Okay, just to prove this, we just have to apply angle bisector theorem 2 times. Understand that? So that was the proof. Okay, and now I'm going to provide you a kind of question which we have been asked in previous year examinations, just for the better understanding of this concept. Okay. So question says that in triangle PQR, in triangle PQR, in triangle PQR. Okay, PQ is equal to 13 centimeter, PQ equal to 13 centimeter, PR equal to 14 centimeter, and QR equal to 15 centimeter. Understand that? I is in center, I is in center, I is in center. Okay, and PT is angle bisector of angle P. PT is angle bisector of angle P. PT is angle bisector of angle P. Then find PI ratio IT. Then find PI ratio IT. So this is a kind of question over here, and we will discuss this. Firstly, based on the information provided here in the question, we are going to draw the diagram. Okay, so this is the triangle PQR. Okay, and PQ is provided equal to 13, so I'm mentioning 13 this, and this is 14, and this is 15. And in the question it is said that PT is angle bisector of angle T. So PT is angle bisector, so I is in center and I will be on PT. So this is I, suppose. Now we have to calculate PI ratio IT. We already know that PI ratio IT will be equal to PQ plus PR ratio QR. Yes or no? According the concept we discussed. Okay, so PQ and PR are 13 plus 14 ratio 15. Understand? 13 plus 14 will be equal to 27, and this is 15. Now I'm gonna to calculate these ratios, simplify these ratio, and we can cancel both of these values by 3. So it will be 3 9s are 27, 3 5s are 15. So PI ratio IT is 9 ratio 5. Okay, so it was all about Incentre. Now we have completed all the concepts and the derivations related to the Incentre. Okay, in previous session we discussed what is Incentre, how can we find out Incentre in a triangle, and later on we discussed that how can we calculate angle on the Incentre, that is 90 plus half of opposite. Okay, and after that we discussed two basic formula of the length calculation of Inradius. In today's session we discussed two more formulas for the length calculation of Inradius, but those were specific formulas, one for right angle triangle and another for equilateral triangle. Okay, and after that we discussed that in which ratio Incentre is going to divide the angle bisector. Okay, so you have to keep all these things in your mind, and all these things are just gonna to help you. Stick on your plan, believe in yourself, just believe in consistency. Okay, you know, consistency and the discipline are gonna to take you at another level. Thank you so much. Thanks a lot.